will kick off this track with a look into security in cloud-native applications and ask, why is security so often left behind? Our first speaker is Kranz from Sysdig. He's the head of solution engineering in the European, Middle East, and Asia area. And he will walk us through the various stages of a cloud-native application, potential security risks, and how to mitigate them using either open source tools or commercial tools. I hope we all have a better view of bringing continuous security to our cloud-native software development life cycles and know how to be prepared for the worst-case scenario. So, welcome, Chris. The stage is yours.
So, as the guys very kindly introduced me, I'm Chris Kranz. Not only do I work for Sysdig on the commercial side of things, I do want to be very honest with that. Although I do work on the commercial side of things, I'm a big proponent of open source. I do a lot of these talks around talking about the open source offerings that we contribute to. I'm also an Open UK ambassador, where we as an organization try and an open source organization trying to promote open source or open technologies. It's not just about the software there, it's also about open data, open technologies, other things. I'm a firm believer that open source is absolutely fundamental to us all, and improving the way we do things. But jumping straight in, so as the agenda talked about, so we're going to kind of talk around the application lifecycle within a cloud native app. We could kind of straight in here. So what we see here is the kind of a couple of the three, I guess, main phases. You could break this down into more phases, but this is the way that we see this. You've got the kind of the build side of things, and this is where you're doing image scanning, obviously for vulnerabilities, but you're also looking at build best practices here. You're also looking at kind of the platform configuration. So have you, in a Kubernetes world, have you actually configured Kubernetes in the most optimal way? Are you exposing, as we saw from Tesla in the past, are you exposing your management console with no RBAC directly to the internet? These sort of things. This is where I see a lot of people start at when it comes to security, making sure that your builds, you've got visibility on the vulnerabilities, but you then start digging into more details around, okay, are we managing our secrets properly? Are we exposing the right services out of our containers? And when you get into the cloud stuff, are we exposing SSH to the entire internet? Are we securing things properly? Are we using end-to-end TLS where it's appropriate? Have we got S3 buckets published to the world? Another common theme that we see in news articles. Moving across to this, once you've built your applications and hopefully in a secure way, you're then going to kind of jump into the runtime side of things. So this is almost where you're looking for common kind of patterns here around misconfigurations or things that you don't want to be happening. We all know that you shouldn't be SSHing into boxes anymore these days, especially if you've got that automated build, especially if you're trying to adopt GitOps. So as soon as you see the kind of an interactive shell being spun up on any of your machines, it's definitely something you want to be aware of, you want to be alerted to. There's a wide variety. I think in the past, most security really was framed around runtime protection. It's where you get your firewalls from. This is where you get things like OpenSCAP from Red Hat, from the Red Hat teams, where you get things like seccomp profiles, those sort of things that really restrict what your applications can do. But of course, there's the anomalies. The stuff that you don't yet know is going to be an issue. And that's where we get into some more modern approaches of kind of baselining your applications to understand what they do. On the flip side to this, I'm seeing a lot of kind of security folks or people with a security mind being really interested in kind of the monitoring side of things. What looks normal from an application throughput? What looks normal from a pattern of people talking to Kubernetes, talking to the Amazon API? This really helps give you kind of some of those early indicators of compromise or early indicators of threats. So I'm seeing a lot of people kind of maturing in this space, and that's the monitoring is no longer just for the app teams to say, is my application okay? It's now also for security folks, for platform folks to see, are we providing the right level of services? Is there any threats that are coming that you should be aware of? And then finally, and I find this kind of the last stage of what people do is the response side of things. We call it rapid response. But being able to say, okay, something bad has happened. We're not sure what it was, but something has happened. How do we approach this? How do we solve the potential problem? This is where, you know, we just some in the chat, some references to things like SolarWinds, the Node.js, you know, with the npm libraries and stuff. These incidents took a fair while to be noticed, to be a bit blunt about it. And I guess, you know, it's then once you do detect that, it's bad enough detecting something. It's then really dipping into the details. You know, Teppo at the beginning there was talking about GDPR. A core part of GDPR is once you get a breach, is then knowing, do I need to make a statement about this? And I think you've got 72 hours to discover that, to do the investigation, and then work out if you need to make a public statement, a disclosure of what has actually been stolen or viewed. So I think this is important, and I think a lot of organizations don't necessarily have a mature response to this, mature approach to this, in part because it's kind of you are planning for the worst case scenario. It's not that people don't like doing that, it's just that it doesn't always get priority. You're going to do the quick fixes first, you know, in terms of securing your build, doing runtime protection and so on. But I'll jump into some details about how hopefully we can approach this sort of thing. Lots of text on screen, mostly so folks, if I'm talking too fast or if you can't understand me, you can kind of read through this. But these are kind of the typical phases that I see talking to, you know, paying customers or open source users around the phases they go through in terms of that cloud native. Obviously, you start with monitoring. You need to know if you're being successful with what you're doing, and then, as I touched on before, you kind of start doing the image scanning. A lot of folks get this for free. If you're using, you know, Quay or Docker Hub or whatever it is, a lot of the time you've got image scanning baked in. But then people start maturing in that approach. It's not just about vulnerability management, as I touched on earlier. It's also about understanding, are you handling your secrets properly? Are you doing undesirable activity within the container? You know, as you deploy an image, are you doing kind of live patching at that point? It's definitely something you don't want to be looking into. So that idea, there's lots of different the practices there. In terms of the runtime security, then kind of moving across, this is where I think I've been a DevOps engineer in the past, and one of the challenges is you sit down and you talk to the dev teams and the app teams, and you say, okay, what's the baseline good look like for your application? And some people absolutely know this, but there's a number of people who don't know this at all. So it's like, well, I'm not sure what my application should be doing. I'm not sure at what point is what's my 95th percentile of load where I start compromising on latency, response times. At what point do we need to start scaling out? What are the common ports being used, both ingress and egress? A lot of people would know, well, I set my Nginx server to respond on 443 because we're doing TLS. I have no idea what services I'm talking out to. So I think that's understanding this is quite complex. So where the idea of profiling comes in, to baseline what an application looks like, what a known good looks like. But I think this is a really important thing to understand. You can knock off the common things. You know, I don't want people SSHing in. I don't want people using port 80. I don't want people using telnet, certainly. So you kind of create those firewall bases, but then it's getting into more details, especially as we get into the gist of microservices and cloud native. The idea here is that a lot of what we're deploying becomes the perimeter. In the past, you've got your data centers, and on the edge of your data centers, you've got your physical firewalls. In the new world, you've kind of got everything is on the perimeter. You're deploying everywhere. So the idea of actually being able to isolate individual applications is really, really important. And then finally, as we all start, hopefully many people watching, either on the live or on the recording, people are moving much more into running your cloud native workloads in production, or you already do. You have been doing for years. This is when you start getting the government risk and compliance teams really paying attention. Oh, so you're handling payment information, you're handling card information, you're just handling a little bit of user information, some PII. This is when the compliance teams start having a look into this and say, okay, well, what is in scope, and then what is actually you doing to meet the compliance requirements? And compliance is a beast of a topic. There's lots of different things you will need to look into this, and it can be really hard to map through not only what is in or out of scope, but also what rules you need to put into there. So this is the typical journey I see from folks. And then, the common question I get is, why can't we just use our existing tools? I've got these firewalls in place, I've got these security tools in place. Why can't we just use them? I think Cloud Native comes with its own set of challenges. First of all, they are ephemeral and immutable. And I get called out on, I know not everyone understands ephemeral and immutable. So ephemeral is the idea that it is short-lived. It's not always going to be there. A lot of the traditional tools take an approach of, I'm going to do a routine scan, I'm going to do things on a scheduled basis, and a lot of containers are so short-lived that actually they fall out of those different scans. So you want to be approaching this much more real-time in order to get that ephemerality. Immutable is, when I got a problem, I'm going to kill it, I'm going to redeploy it. The idea is that my containers, my applications, my cloud-native workloads shouldn't have live changes. This is the whole idea of GitOps. I want to have a workflow so I can just keep pushing new versions, new applications, new replacements. And once it's been pushed, it should never change. So it's the idea of the immutability. Whatever I do to that, it shouldn't change fundamentally from the template. Another challenge here is they're distributed systems. I can't just point at one IP address and tell me the health of this, or what's the state of this, or what's the configuration of this. Now I've got this deployed across tens or hundreds of different instances, maybe even multiple AZs, availability zones. Potentially, I don't see many people doing this, but it is what marketing love to talk about, potentially across different cloud platforms. I'd love to hear if anyone's doing multi-cloud with a single application. I'd love to hear about it. Seems more like a marketing pipe dream than reality. But this just makes it more complex from understanding what are my security point of view right now. Open source and code reuse. Now, this isn't like I started with. I'm a massive fan of open source, and I think it's a huge benefit to the organizations. But the challenge here is that when we were using proprietary software or software that we entirely wrote ourselves, you knew everything about it. Now we're pulling in open source from the internet, and I know you can. The whole benefit of open source is you can go and look at the code. But I'm curious of how many people do look at the code. Again, to Nikolai's points, the whole NPM thing. If people had looked at the NPMs they were pulling in, they would have seen the command and control code that would have been put into the popular Node.js libraries. But it took a couple of years. I think if I remember correctly, it took a couple of years to actually identify that. So this is just a risk that people need to be aware of. I don't ever want to discourage people from using open source, because it absolutely is a great way of doing things. You shouldn't be reinventing the wheel for a bunch of different applications. And then code reuse. We're all pushed into doing agile and all the rest of it. That pushes us to deliver more and more quickly. And we could do that more intelligently. So it's pointless kind of rewriting stuff that already is available. But we got to understand the security implications of doing that as well, and make sure we're aware. You need to go into these eyes wide open. And I touched on this before, the idea of everything is the perimeter, so zero trust. You don't have an edge where I can strap some physical firewalls. Even virtual firewalls are a little bit cumbersome to strap around all the applications. So I'm going to touch on one of our large customers, Goldman Sachs. There is a link here. We'll share that. We can share this with the slides and stuff later on, or come stop by the booth and we can talk about this. So Goldman Sachs, they were going through the DOI approach. They were looking at they had some traditional tools in place, and they wanted to kind of get visibility of containers. Now, their containers were incredibly short-lived. Some of them only existed for 30 seconds or less, and their traditional tools were polling every hour. So they just had no visibility of what was going on in this. The other side of this is just talking about the scale, and this is, the more and more mature we get in the Cloud Native and stuff, the more and more we hear stories of just this immense level of scale. These guys are running over 100,000 nodes across different clouds. To my point earlier, not the same application across different clouds, just across different environments. They were running, it was actually C groups rather than traditional containers, but running those details on there, so multiple workloads per node. So it was a huge amount of scale for them to handle this. And they didn't think anything was out there to do it. Obviously, we got into discussions with them. You can read more in this case study. But I want to jump into, conscious of time. I've been talking for 15 minutes. I've not even talked about anything useful yet. So I want to jump into the security side of things. In our view, there's kind of two sides to it. You've got the prevention, like firewalls and so on, as I touched on before. And then you've got your detection. I think your detection is just as important as your prevention, because if you just set up all your firewalls and assume that they're blocking everything, you're kind of blind for are people doing backdoors that I don't know about? Are we executing 0 days that maybe take advantage of flaws in my firewall, or just my firewall design? So the two of these things are absolutely complementary. They are really important to use these two in combination with each other. So I give bring in my dog. She's usually sat behind me, but she's not today. I've got locks on my front door. I've got alarms. I've got locks on all my windows. But I've also got a teenage son. If he leaves the front door with it and he leaves it wide open, which, let's be honest, he does occasionally, I'm also glad I've also got a German Shepherd. So this is Jabba the Mutt. But she is rubbish at actually attacking anyone or being vicious in any respect. But what she's brilliant at is alerting me. So if anything suspicious happens around the house, she will bark. She will tell us all that what's going on. And that's really kind of what we're looking here from that detection side of things. Yes, I've still got my security. I'm not going to leave all my doors wide open just because I've got a German Shepherd. But it's a strategy of using both of them. I lock my house up and I make sure my dog's happy. And then she does everything in the world to make sure that we're protected. And that's really what we're talking about here. So introducing Falco. Falco is a CNCF tool. It came from Sysdig Labs. Our founder was Sysdig's founder was the guy, Loris Dejuani, very, very smart chap, was one of the guys behind Wireshark. So we kind of took that understanding of what, that low-level information stream and looked to apply it to the security world and the detection world. So we came up with Sysdig, the open source components there for monitoring and troubleshooting, and then Falco from a security perspective, which eventually the CNCF adopted it. The idea here is that it's kind of behavioral activity monitoring. We're looking for anomalies with the way applications are performing. And I'll show you the details on how we do that in a second. This needs to make sure we've got the full context of the containers or the orchestration platform. So it's really important to talk to things like Kubernetes, get the context of, this particular thread is actually part of a whole microservice. And that's important to be able to do as well. I'll touch on the notifications things with things like Falco Sidekick, and obviously from the open source perspective, encourage folks to get involved with Falco. We've got a fantastic open source community. Just head over to falco.org. We're also in the Kubernetes Slack. There's a Falco channel there. Lots of different ways to get involved in this, even just as a consumer. So let's kind of drill into the fundamental where Falco came from. And this is from the manual pages for syscalls. The syscall is the fundamental interface between an application and the Linux kernel. I know you all can read that, but I thought I'd say it anyway. So why system calls? Because every application has to talk to the underlying kernel, it means that we get visibility of everything, whether this is the processors running, whether this is network, whether this is file IO, whatever it is. And because we're also pulling in that context from Kubernetes, from containers, from AWS, for example, you've got that richness to say, okay, I can see this application, this is a MongoDB, but it's running a shell script. That shouldn't be something that works, that normally happens. Or I've got a MySQL database and suddenly it's making outbound network connections. This sort of detection is really interesting, and it gives you that really low level coverage. The other advantage here is because we're tapping in directly to the kernel, it's really, really scalable. So you're not adding sidecars, you're not doing LD preload, kind of injecting code into your containers, into your workloads. They work as is. Now, I'm talking here a lot about Kubernetes and containers, but this works with normal EC2 instances, normal virtual machines, even physical hosts. All you're doing is tapping into that Linux kernel, pulling out the system calls and making decisions on what to do with that. And the decision is just, remember, this is just about detection. This isn't prevention here. I'll talk about some workflows in a second, though. The other side of this is Kubernetes. So I'm not going to read the whole block of text, but the Kubernetes API has similarities to system calls. Everything you do, whether it's a user activity, an application interacting with the Kubernetes API, or even the control plane itself, all of that work goes via the Kubernetes API, which again is a great source of data. So what we're doing here is, in addition to the system calls, we're pulling out that Kubernetes audit logs, and this has a slightly more richer context than just the system calls. So the system call will tell us you've got a terminal shell being run inside a container. Kubernetes will tell us this particular user authenticated, connected from this IP address, and then ran it to this particular container. So it kind of gives us the rest of that picture. And then you can start interrogating Kubernetes itself. So someone's running someone's doing a deployment with a config map, and that inside that config map there is something that says, AWS access key or password, and it's not, it's not an encrypted secret. You can also do things, looking for abuse. If suddenly loads of stuff starts being deleted, again, you've got that awareness in here. So these kind of different data feeds are really important from Falco. And what I actually don't have a slide on this. Apologies for that. But the different data feeds here. There's an open a web service that Falco runs. So we are open for adding additional data feeds into here. So one of the things that Sysdig, the commercial side, are working on at the moment is adding in kind of cloud logs and cloud activity into that. But again, this is an area to get involved in from a community perspective to look at different data sources. Falco rules are written in YAML. So here you can see an example rule. We use lists and macros. So here you can see we're referencing a couple of macros just to make things easier. So this shell proc is just a list of different things like bash, shell, KSH, ZSH, etc., etc. Identifying whether it's a container. So basically the container ID is not equal to host, whether it's an interactive shell. Now, I know this is probably a new language for many, but if you look through this, for the most part, it's fairly self-explanatory. We know this is a process.name. We know that there's container. We're identifying, oops, sorry. I didn't mean to skip forward. We know that we're identifying the repository where this container image comes from, and so on and so forth. So there's a whole load of existing rules that come out of the box, which give you a really good kind of starting point to create the rules, write your rules, and customize them for yourself. Jumping on. If you're not interested in customizing the rules, you can also go to Cloud Native Security Hub, where we host a bunch of kind of pre-written rules, pre-written workloads, rule sets that you can just download and import into your Falco library. This is, again, useful if you're just making Falco more approachable for the enterprises who just want to focus on the detection side of things and actually using that data for something and less focus on spending lots of time writing those rules. And then what happens once you got the alert? So Falco, like I say, is the detection engine. All it's going to do is pipe out to a couple of different methods, but it's just going to pipe out the event that it sees. What we then want to do is kind of make that a little bit more advanced. So this is introducing the Falco Sidekick. The Sidekick runs alongside Falco, generally as a sidecar or something. It takes the feeds off of Falco and then allows you to push these out somewhere else. Every time I give this presentation, something new has been added. So if you look through this list and think, oh, I wish Falco Sidekick did this, it probably is already in there, or it's something to request from the community to add in there. This obviously takes that logic of integrations outside of the Falco core. So Falco is kept for, this is the detection engine only. And then that decision engine on what am I going to do with that, you can get a little bit more logic, a little bit more, or a lot more complicated with that and push that out into the Sidekick. So taking that whole microservices approach to things. This is an example, a quick example of what you can do with this. So this is leveraging kind of a response engine along with Falco and the Falco Sidekick. So here you would see some sort of anomalous activity. This would go into some sort of event handler. We see, if you're using Amazon, this could be SNS. If you're doing full CNCF stack, it could be something like NATS. Whatever it is, you can then make a decision tree from that. So it could be that every single event that happens, I get a notification to Slack, but I also get an event happen to stop that, every event sends a notification to Slack, but for some events, I then go back to Kubernetes and kick in a workflow to terminate that workload or do something else with it. So another case study here. So this is a customer we worked with very closely in the UK, WorldPay. Again, case study is linked here. I'm going to skip through. I'm just conscious of time a little bit. I'm talking a lot about Falco because I do love it, and I want to get onto some other topics. But the guys at WorldPay, obviously they run a payments platform. They were really concerned about being able to make this scale and being able to give the breadth of coverage that I talked about before. And so that's why they kind of start talking to Sysdig. So introducing the commercial side of things. Falco does the runtime detection, as I talked about. The Sysdig Secure DevOps platform, what we're doing here is covering much more breadth around the security, as well as that monitoring piece. Different components to give you different visibility of a different kind of richness of metadata attached to that. So we're looking to cover those different timelines that I talked about, the build process, the runtime security, the profiling, compliance, and then finally that incident response, troubleshooting, and so on. As well as Sysdig Monitor. I know we're focusing on security today, but Sysdig Monitor, which is Prometheus compatible, allows you to make Prometheus and kind of give it that scale and robustness that you expect that from an enterprise tooling. I've kind of talked about these really. So these are the different areas of functionality from Secure, and then pretty much the same sort of thing from Sysdig Monitor. The idea here is to absolutely integrate it into the pipelines. So for me, I know that marketing don't always necessarily agree with my statement on this, but I think that something like Sysdig is best used when you don't see it. You want it to be embedded, so as part of your build process, you just get the feedback to say, okay, this is configured badly, here's a vulnerability report. So you've got that quick intelligence. You could even automate that whole workflow to say, okay, here's some negative feedback, go have some automation to fix that negative feedback. Same with on the run side of things. You want to have that, you'd use things like the Kubernetes autoscalers to feeding off of metadata, feeding off that information, that runtime security from Falco, feeding that into a SIM where you're collecting all those different events from all those different platforms as well. And then the response side, this is a combination of using things like a SIM, like Splunk or so on, and using the tools within Sysdig to give you that incident response, the details there. And then very quickly, right at the end now, talking about the incident response. This is something that again comes from our open source roots. There is hopefully you can just see that link on the bottom there. Sorry, the screen sharing thing covering it for me. So you can go check this out. So this is really where Loris came from that Wireshark view of taking how can I take Wireshark, the packet captures that Wireshark produce, and pushes it down into the system call and so on. So here's the idea of taking a Wireshark like capture of a system. So we've got captures of system calls. You can see here, you can see the activity that's happening, user activity, some log files, some errors, some network stuff. And then from there, you can drill right down into what is the file IO that happened with this particular system call. So real kind of breadth and depth in this. Now on the commercial side of things for Sysdig, we can do this in a more automated fashion. So when we detect an incident, we'll automatically create a capture for you. From an open source perspective, you can put in your own automation workflows to create these captures, or you can just create them manually. Really useful when you've got an incident, an issue, you can create the capture, recreate the issue, close the capture, go and analyze it. Again, on the commercial side of things, we've then got this fairly detailed activity audit, but loop back through to those two different data sources. So keying the system call activity of commands, network activity, file activity with the authenticated activity of Kubernetes commands. And I wanted to make sure there's time for chats. Time for questions. I saw there was a couple of questions coming up, but I think that they were answered in the chat for folks. Quick look through. So, Ardcos, what about CloudFormation? Any ideas on tools to use for security scans? There was, and I've got a text file on my desktop that talks about some of this stuff. There are some really good tools for analyzing CloudFormation templates. Yeah, I think actually Michael Mann has given a good example there. Chekhov is one of those ones that I looked on that. So thank you, Michael.
Yes, there's one new question that just came up as Anup is asking how much support is available for Windows containers?
Great question. So from a Sysdig commercial side of things, we've got the image scanning that supports Windows containers. From a monitoring perspective, we can support Windows containers. For runtime security, which is also the same for open source Falco, there are some proof of concepts internally at the moment making that work. It's one of the challenges has been how Windows or how Microsoft have approached containers, because they effectively had a view of almost like Kata containers, where each container was wrapped up in a Hyper-V virtual machine, which meant there wasn't like a shared kernel as we have in Linux containers. That's been changing as Microsoft have matured and improved their container landscape and stuff. So we should have Windows support for containers both in Falco and in Sysdig later this year. Roadmap from me, so don't quote me on that.
All right. We also noticed that some people in the chat were wondering that you have a nice hammock there in the background. Where can you get one?
Unfortunately, most of my life is ordered from Amazon, so it's just from Amazon. And yeah, you know what? There's some days where the sales team are giving me pressure, and you know what? That's the best place to sit and take sales calls.
Is there any online resources for these?
Yeah, so if you go to the sysdig.com/blog, I think it's that the blogs that we have on Sysdig. Actually, there's a big percentage of our blogs are based on open source, not our commercial tools. There's a lot of stuff. There's actually a recent article. I don't know. I see Mincy and rolled a couple of my colleagues on there. If someone can pull out the 20 best practices for Docker builds, it's a blog we put out about a week ago. There's a couple of other blogs we've done around kind of security best practices, the things you can do. Thanks, Roald, for the link. So there's a couple of articles we've got around best practices on that. Feel free to reach out to one of us. My Twitter is on the bottom of the page. If you've got specific questions, I'm pretty much running out of time. So if there's specifics around best practices, feel free to give me a shout. I'm more than happy to go through that.
All right. Thank you very much, Chris. It was a really great presentation and talk.
No worries. Thank you very much, all. Thank you for the time and the questions. It was great chatting to everyone.